Hello everyone, welcome back to Math with Allison. Today we're working in our curve series, so we're going to be talking about an introduction to polar coordinates. So let's go ahead and dive in. What we are used to working in is Cartesian coordinates, right? That's our rectangular coordinates. We have a point x, y. We go over x and we go up or down y, right? So I just gave a little example right here. Now, they're called rectangular coordinates because we're working on a rectangular coordinate system, right? We have all of these lines up and down. What if I only wanted to work with curves? What if I only wanted to work with circles? If I wanted a circle in the Cartesian coordinates, I would use x squared plus y squared is equal to the radius squared, right? But that is still in terms of x and y. We learned a little bit on how to do this with parametric equations. So here, x is represented as a function of t, y is represented as a function of t. So here's a little example. We have x is equal to 2 cosine t, and we have y is equal to 2 sine of t, and t is bounded between 0 and pi. Now, this is going to represent, in this case, a semicircle since I'm only going to pi, but it's a way that we can have a curve. There is another way that we introduce only working with curves, and it's going to be the polar coordinate system. So now we're working, instead of x and y, we're going to be working with r and theta. R represents the radius and theta represents the angle. So let's go ahead and talk about what this looks like. Here, first of all, let's just talk about the circles. So if you can see this first circle, it's going to be all of the points with a radius of 1 from the origin, right? Now, if we go out right here, we're going to have all of the points with a radius of 2 from the origin. So the distance between the origin and all of these points on the circle is 2. If we go out one more, right, it's going to be all of the distance between 0 and 3. So that is going to be those little circles right there. And we're also working with a specific angle. So if we go, we have our initial angle is always going to be at that positive x-axis. So it's actually called the polar axis. And it's going to be our initial starting point. From there, we're just going to increase like we normally do with our theta. So here we go up to pi over 6. We go to pi over 4. We go to pi over 3. And then we go all the way to pi over 2, right? So the point that we can represent is r comma theta. It's going to be the radius comma the angle that we're at. So here's an example right here. I have a radius of 3 because I go out 1, 2, 3 units away from this origin. So that's going to be 3 comma, and then the angle that I'm at the angle pi over 6. So let's go ahead and try out an example. We're going to go ahead and plot these 3 points. So Q, R, and S. I suggest you just first go to the angle. So let's go ahead and start with Q. We're going to go to 5 pi over 4. So 5 pi over 4 is going to be down here. And what we have is that we're going to a distance of 1. So we're just going to go out to our first little circle right here. And that right there is our Q. Let's go ahead and try R. So here, let's start with the angle. We want to go to 7 pi over 4. So 7 pi over 4 is going to be over here. And now notice our radius. Our radius is going to be -1. So instead of going outwards 1, what we do is we go backwards on that same line. So here is our 7 pi over 4 line, and then here is the image of it. The image of it is on this side. It's reflected across the origin. I'm going to go out 1 on that angle. So it's like I'm going out this way, but instead I go backwards. So when you have a negative radius, always go backwards from your angle. Now, our last little example here is going to be, let's see, we did a Q, we did R, we're going to do S, do in purple. Okay, so now notice here, our angle is going to be negative. So instead of going in the positive orientation, we're going to go in the negative orientation. So if I go this direction, I arrive at negative pi over 2, negative pi, and then we go to negative 3 pi over 2. So I'm at negative 3 pi over 2, so I'm going to write right here, negative 3 pi over 2. And now what I want to do is I want to go out a radius of 2. So I'm going to go up 1, 2. And there, right there is my point. Let's talk about the different properties that we see. So first we have a point r theta, radius, angle. Now if I add 2 pi to the angle, I'm going to arrive at the exact same point. So let's try this example. We have 2 and pi over 6. So first, let's go ahead and locate our angle, which is going to be right here, pi over 6. And we're going to go out a radius of 2. So 1, 2. And that right there is going to be our point. All I did was I went a small angle of pi over 6. Now if I go to 13 pi over 6, 13 pi over 6 is equal to pi over 6 plus 2 pi. So what I'm going to do is I'm going to go a full 2 pi and then an extra pi over 6. And I'm going to arrive at the exact same point. So it does get a little repetitive because we complete one period in 2 pi. So if we start adding 2 pi, we're just going to be going around and around the circle, right? So another property, we have the second one here, is that r theta and negative r theta are reflections of each other through the origin. Let's go ahead and see what that means. So here we have an example, 3 in pi over 3 and then negative 3 in pi over 3. So let's go ahead and start off with our angle. We want to go to pi over 3, which is going to be this guy right here. And we want to go a radius or a distance of 3. So we go 1, 2, 3. It's going to be our point right here. Now let's go and plot the second point. We want to go to negative 3 pi over 3. So we're going to start with the same angle, but we're going to go backwards on it. So we want to see the reflection on the other side. So we go backwards 1, 2, 3. And so they are reflections, these 2 points, of each other across the origin, right? It's like if you held a mirror. I held a mirror right here. I'm going to see them across. Now let's go ahead and talk about another way that we can represent this point. So here we have negative 3 pi over 3, right? I want to talk about a different way to express it. And so we know that this is equal to 2 pi over 3, so this one must be equal to 4 pi over 3. So another way we can express this point, instead of negative 3 pi over 3, we could also go an additional pi angle. So instead of stopping at pi over 3, I'm going to go all the way around to 4 pi over 3. So my angle is going to be 4 pi over 3. And now I just have a positive radius. I'm just going to go out 3. So another way to represent this point is 3 and 4 pi over 3, right? I added pi to my angle. Now I can do the exact same thing. I can just go in the backwards direction. I could just go ahead and subtract pi from my angle, right? So if I subtracted pi from my angle, I'd go to 3 and I would go to negative 2 pi over 3. And that leads us to the third property. We have negative r theta and r of theta plus pi or r of theta minus pi are all the exact same point. So notice here, there's not a unique way to express a point. There are multiple different ways that you can express this point. And then the fourth little property is that the origin is also called the pole. It is any radius of 0, and any angle theta. So the radius, when it's equal to 0, it doesn't matter what angle that you're at because you're just going to be stuck at the origin because you're not going outwards any distance. So that is all I have for us today on this video. If you enjoyed it, I have many more like it, so make sure to check out my playlists. They're linked down below. Otherwise, please give this video a thumbs up and comment other problems or topics you'd like to see done. Thanks for watching.